All right, I'm Dan. I'm a solo developer. I've been working on a website called Booko for the last 13 years. This is actually a lightning talk that got upgraded about half an hour ago to a talk. So I apologize in advance if it's a bit off the cuff. And welcome to today's Postgres meetup. Anyone upgraded to Postgres 18 yet? Yeah? Got some of that async speed love? Good. Many people host their own, just out of curiosity. Wow, everyone uses a managed Postgres. Amazing, okay. All right, so recently I discovered this feature in Postgres called Tablespaces. When you install Postgres, you get a default tablespace, that's the data directory, and all your tables and your indexes, they automatically just get created in that tablespace. You can create more tablespaces. And in fact, in the olden days when we used to have spinning Rust hard drives, it would be common, I think, to have tablespaces in slow disks and fast disks. And you would put your indexes on the high-speed disks and you put your bulk data on the slow disks to really try and get every bit of performance out of it. But since most enterprise databases nowadays have a homogeneous fast disk, it's become less sort of common. But I host my own Postgres, and I host them on VPSs. And when I buy a VPS, I size it based on the memory and the RAM, not the disk, because you just attach a disk and put your database there. However, I really wish I'd done performance testing of the remote volumes compared to the local volumes, because it is substantially different. So, this was a blog post that I'm turning into a talk. So here's how I did the testing of the performance between the local drive and the remote drive. So the local drive in a Hetzner is a NVMe, and the remote volumes are like Amazon's EBS, Elastic Block Storage, just another kind of network block device. So on Hetzner, the performance gap is amazing. It's nearly 5 times slower to write to a remote volume and 3 times slower, or a third of the speed, to read. So that was a bit of a bummer, and so I was wondering if there's a way I could make use of all this free space on my VPS. I had about 100 gigabytes of space, and Booko's database is about 250 gigabytes. And then I remembered back in the olden days when I learnt about Oracle tablespaces, and did a quick Claude search or Claude question and found out that Postgres actually has them. And so then I thought I'd give that a shot. So what you can do is you can create a tablespace on the local volume. So here I am, this is create tablespace on the local fast one. That's just a directory on the NVMe drive. And yeah, so once you've created your tablespace, then you can move indexes and tables to that tablespace. You can set a default one, and I think by default when you create a table, when you add an index to it, it'll go into the same tablespace. But what I wanted to do is have a mix and match. So what I was interested in doing was moving indexes onto the fast disk. So you can move an index between the default tablespace or any tablespace in another with an alter index like this. However, as I learnt, if there is a foreign key constraint on it, then you need to, oh, that's being cut off, re-index it. Yeah, you do a re-index command. And so that basically rebuilds it. And there's the command for moving the tablespace, the table itself rather than the index. Let's have a look here. So these operations are all exclusive locks. So you will, yeah, well, you know what that means. You need to prepare accordingly. I run a second database in a secondary, like a logical replica. And so I did the timings for moving indexes and products because that database, it's not being queried. So it turns out mostly it doesn't take very long. And for small tables and indexes, I just moved them live during the day, and it was just a few seconds. The main table in Booko is the products table. It's got about 12 gig of data, and these are the indexes that I wanted to move. Yeah. So I wanted to move the primary key index, and I wanted to move the index on the, it's called GTIN, but it's the ISBN. So it's a number, sometimes it's got letters, so it's actually a string. And that's the sizes of them. And that migration took maybe it took 2 minutes. And so I just did that late at night. That's just a little outage. And to find out how that affected performance, I ran a PG bench. So this is a PG bench, and it's going to select title author from products where product ID, or alternatively via the ISBN, which is via a string. Okay. So here it is, the performance without moving anything onto the local disk. So that was about 3,100 transactions a second, TPS, yeah, transactions a second. And then once we moved, this is just the indexes. It went to 5,870, which is a massive increase in performance for free, just for a small amount of outage. So yeah, absolutely worth it if you have storage tiers of different performance characteristics. You should consider creating a table space, moving some indexes. Moving the wall obviously has another advantage, another performance boost you can get, because every write to a Postgres database will first go to the wall and then gets flushed out into the disks, into the tables. So when I wrote this was on Postgres 17, and the default table space and therefore the wall was on the remote volume. But a few weeks ago I migrated to Postgres 18. And this time I put everything by default on the fast disk and then just moved the big stuff off to the remote volume. I don't know if you guys tune your databases or if managed databases do that, but you can set, these are configuration items I'd only ever seen in the Postgres config. So basically it's telling Postgres what's the cost of sequential access, what's the cost of random access, how much effective current I/O can we do? And those numbers are different depending on the kind of disk you have. So for a spinning Rust, you know, the sequential page cost, maybe it's low, but the random page cost is high because it has to seek across, wait for the disk to spin around and to the blocks to be underneath it. So, but with an NVMe, the random page cost is much, much lower. So if you have table spaces with different performance characteristics, you can also set characteristics per table space, which is really handy. Okay, so that's it. That's my lightning talk. Anyone have any questions about that? Yeah.
So it's really helpful. So my question here is, have you tried to... Hello? Is it working?
Hi. Yeah.
Okay. So first of all, thanks for this tip. It's really amazing. So I saw here that with your example, you moved all your indexes of that table to the NVMe drive.
Yeah.
So have you, is there any penalty cost for moving just one index, or some of the indexes to the NVMe and of the same table and the others on the external volume?
So the question is there a performance penalty for having your indexes not stored next to your table?
No, some indexes next to the table,
yeah,
and some indexes on the NVMe.
Yeah, no, not as far as I'm aware. I did look into it, but I didn't find any performance issues, at least none documented. And the performance from PG Bench was pretty good. Although that was only for reads, I should point out, not for writes.
Yeah.
And indexes will be updated obviously only when you write. So I guess it's possible, but I don't think so. Not that I know of.
Yeah. And have you tried, and did you compare the performance of moving the indexes in the memory compared to the NVMe?
No. No, I'm a big believer in letting Postgres do its thing.
Okay.
I don't want to try and manage its memory. It's very good at managing its own memory.
It is, yeah. Cool. Thank you.
Actually, that's why I stopped running it in Docker.
Question? Hello. Down the bottom, you had some configuration you were setting.
Uh-huh. Oh, yeah?
What's the system for figuring out which settings to change, and how did you arrive at those numbers? I have a system, and it's pretty much read Stack Overflow and hope.
This is where I get most of the stuff from. So 16, I'm not sure if I think it should tell you that. 200, and we'll say, right, so we can choose, right? And then, so, come on, please tell me that. Ah, thank goodness. Random page cost, effective IO concurrency. So I get it from here. So you can see, what is it? Random page cost is 4. If we go to an SSD, hopefully it's going to be lower. Yeah, 1.1. And if we go to a SAN, it will be still 1.1. Probably depending on how fast your SAN is. Yeah, so that's where I go. And also Claude. Yeah.
Any more questions?
I think a lot of people are just using RDS. Yeah.
Hi. I don't know if I missed, I know there was a section on the query tuning.
Query tuning,
Or,
this bit.
yeah, that's right. So I don't know if it's covered there or not, but do you know if the query optimizer actually takes into account where the table space is located? So does it keep track of?
It definitely uses this data. So if you tell a random access cost high, it'll do, as far as I understand, it'll prefer to do a sequential scan of a table, of an index, rather than trying to jump through with random access.
Yep.
So it'll tune how it accesses the data like that.
Yeah, so it's independent of the actual table space that's, that'll be reflected in the actual overall statistics, I guess, when it's working out.
Yeah, that's how I understand it. I understand, yeah, like, especially when you want to figure out what the cost of a query is, and then you're going to do, it might be weighing up, will I do a sequential scan, or will I try and use this index? And so if it's going to be lots of random access, maybe it'll prefer a scan.
So simply by improving the performance of the index, it'll be favoured when it comes to actually...
Yeah.
Yeah, got it. That's good.
Sure. Thanks.